Okay, so we'll finish up section 7.2 here, which is trigonometric integrals. We looked at some integrals involving sines and cosines, and right now we're looking at some integrals involving secants and tangents. So let's see, we did this problem in the last video here. Right now, so what if we want to integrate only secant x? Well, this involves a little trick that I wouldn't expect anyone to know how to do, so I'm just going to tell you what we're doing here. With secant x, you're going to multiply the top and the bottom by secant x plus tangent x. Totally obvious, right? Not really. But the reason why we did that, so when I distribute the secant x into these two terms here up top, the reason why is because that sets us up with a u substitution. Okay, if I let u be the denominator, secant x plus tangent x, then du is going to be secant x tangent x plus the derivative of tangent x is secant squared x and then dx. Well, that's exactly what I have in the numerator there. Okay, so I'll be able to knock this out with the u substitution. My new integral then would be 1 over u du. And that is the ln of the absolute value of u, don't forget about the absolute value bars, plus a constant. And then now u is secant x plus tangent x, so replace u with secant x plus tangent x, and the answer then would be the ln of the absolute value of secant x plus tangent x plus a constant. Okay, so this is an integral that we should know. And by the way, you know, when we have integral problems that come up, like any integral that you know, go ahead and give the answer. Okay, like some of the problems, you know, are going to be where you'll have an integral of secant x. Okay, well if we've already done that before, then just give the value. You know, there's no reason to redo it. Okay. Let's try this next example. So, and by the way, if we want to integrate secant squared x dx, that is very easy. That's going to be tangent x, right? Because the derivative of tangent x is secant squared x. Okay. So yeah, let's find the antiderivative of secant cubed x. Well, so the first thing is we need so let me go ahead and split up a secant x from those terms. So we got secant x times secant squared x dx, and then now the option here to do is to use use integration by parts. Excuse me. So if we let u be secant x and dv be secant squared x dx, the rest of this, that's going to be the correct setup that we'll need. Now, I would not have these flipped. Okay, so if I were to let u be secant squared x dx and dv be secant x dx, well, the antiderivative of secant x is this guy here, and that would be v. And if u is secant squared x, I'm going to need a chain rule then to get dv, or du. That'd be 2 secant x times tangent x. That does not sound like tons of fun to have in a new integral. Okay, so again, you know, the idea with integration by parts is that you're creating a new integral that most of the time you can get your hands on then and go right to the answer then. Well, let's see. Du is secant x tangent x dx. V, the antiderivative of secant squared x, is tangent x. Okay. So then u times v, you got secant x times tangent x minus the integral for v du, the integral for secant x times tangent squared x dx is what we have there. Okay, now the next thing I'm going to do with this guy is I'm going to use the Pythagorean identity for tangent squared x. Okay, so tangent squared x is secant squared x minus 1. Okay, and I go ahead and replace that there. And let me distribute the secant x into these two terms. So here's the next line. Also, I can split up the integral into two integrals. Okay, so I got the integral for secant cubed x dx, and then plus, because minus and negative is plus, the antiderivative of secant x dx. Okay, now I know the antiderivative of secant x dx, right? We just did that over here. Okay, so that's that guy. Now, the next thing I'm going to do is I'm going to use some algebra. Okay, we have an unknown over here, which happens to be an integral, and we're subtracting the same unknown on the other side. So let me go ahead and add the integral for secant cubed x dx to both sides. And on the left, then I'm going to have 2 secant cubed x dx equals the leftover on the right side would be secant x tangent x plus, again, we said that the integral for secant x dx is the ln of the absolute value of secant x plus tangent x, okay, and then plus a constant. I'm calling the C1 just because I'm not done with the problem yet. But if I divide both sides by 2, okay, then the integral for secant cubed x dx would be 1/2 times the quantity secant x tangent x plus the ln of the absolute value of secant x plus tangent x, okay, and then plus C1 divided by 2. I'm just calling that C, some constant, you know, and that's going to be my answer, okay? Remember this integral, okay, because this is going to come up again in the next section, actually, and for some miscellaneous other problems, okay? So, yeah. The last couple of examples are where you're using the product to sum formulas. So I've got those formulas here that that you'd want to use. And let's just take a look. I got 2 examples of where you're going to be doing that. So in this first example, suppose that we want to integrate sine of 5x times cosine of 4x dx. Now, by the way, I can't use any u substitution, right, because the angles don't match, right? One's got an angle of 5x, one's got an angle of 4x. So this is not just to go right to the answer or anything like that, or a u substitution. But I'm going to use the product to sum formula, this first one here, where I got 1/2 times sine of, I'm going to subtract the angles times x, and then plus sine of, I'm going to add the 2 angles times x. Okay, well that's what I did there. So when I subtract, so 5x minus 4x, that's x. 5x plus 4x is 9x. And I get a 1/2 in front of the integral. Okay, and I'm adding these 2 functions together. So, well, that makes it nice because now I can go right to the answer, right? So the antiderivative of sine x is negative cosine of x. I'm bringing in the 1/2 there too. So negative 1/2 cosine of x, and then minus, you got cosine of 9x divided by 9, right? Because it'd be a u substitution if you let u be 9x. That's where the 1/9 would come from right here. But then times 1/2 means I got minus a 1/18 cosine of 9x plus a constant. Okay? By the way, this would be the only way to do the problem. Okay? Is you have to know the product to sum formulas. Okay? Now, these formulas aren't used a ton in this class. Just a couple of times you'll need those though for some problems. So just so that you're aware. Okay, and here's another example. Suppose that we want to integrate cosine of pi times x times cosine of 4 pi times x dx. Well, again, the angles don't match, right? So I can't combine these. I can't just go right to the answer or anything like that. But this is going to be a product to sum formula. Let's see, I guess I'm going to use the last one here on the sheet. So, and by the way, so because, you know, if I were to go to the formula right away here, I'd have cosine of pi times x minus 4 pi times x, that's negative 3 pi times x. Well, the cosine function is an even function. So cosine of negative 3 pi times x, that'd be the same as cosine of 3 pi times x, right? So just to avoid using that, I went ahead and switched these two functions, okay? And same thing, right? I'm integrating cosine of 4 pi times x times cosine of pi times x dx. Well, I'm going to use this formula here. So I'm supposed to subtract the angles and then add the angles. Okay, so if I take 4 pi times x minus pi times x, that's 3 pi times x. 4 pi times x plus pi times x, that's 5 pi times x. And I got a 1/2 there in front of this. Okay. So now I can go to the answer, right? The antiderivative of cosine of x is sine x. I don't have cosine of x. I got cosine of 3 pi times x. So I'm going to have sine of 3 pi times x and then times 1 over 3 pi plus sine of 5 pi times x times 1 over 5 pi. And then the whole thing is being multiplied by 1/2. Don't forget about that. Plus a constant at the end. Okay. I think that there's just a couple of problems at the end of this section to do that require using the product to sum formula. And by the way, the only way to do this problem, these last two problems, is to use the product to sum formulas. Okay. But have a go at these problems on page 498, and we'll go ahead and stop right there.